In this lesson, we're going to look at the volume of a sphere. Now, the volume of a sphere formula I've written here, which is a bit of a funny formula. It's different to the rest in the fact you've got an r cubed and you get this 4 over 3, so it looks a bit strange, and it's quite often written wrongly. Even though it's on the formula sheet, people put r squared and 3 over 4 and so on. Now, it's actually harder to prove this formula as opposed to the cone and the pyramid and the cylinder. It uses something called calculus in higher maths, but I'm going to try it using this idea here, which actually works on a practical level. And I'll talk about it in a second. So, if you take two cones and filled them with water, and then you poured them into a sphere, the cones would fill the sphere up exactly. Now, it's particular cones. The radius of the cones must be exactly the same as the radius of the sphere, and the height of the cone must be the same as the height of the sphere. But again, on a practical level, if you did this, if you filled these two things with water and then poured them both in, the volume's the same. Two cones would be the same as one sphere, with the radius the same and the height the same. Okay, so in order to do this, in order to try and get the formula for the sphere, I'm going to take the two cones and add them together. Now, if you watched the previous lesson, then the cone's 1/3 pi r squared h. And we've got another 1/3 pi r squared h. So if we add these two together, we should be able to create this. But what you'll notice up here is there's no h, which I've got h down here, so I don't really want the h's there. Now, h is the height of the cone, but it's also the height of the sphere. Now, the height of the sphere can be thought of in terms of the radius. Now, the radius goes from the centre to the outside, but it also goes from the centre to the top. That's the same radius, of the centre to the bottom. So we can basically say that the height is equal to 2 of these r's, if you like. So I'm going to write that. H is equal to 2r. Okay, so remember, spheres, radius goes in every direction. Radius out there, radius out there, radius straight up and down, or down to the bottom. Now what I'm going to do to kind of try and get rid of the h's here, because there's not one in the formula, I'm going to sub this in. I'm going to substitute it in for there, and also there. So that's going to look like this, which is going to look a bit strange, but if you look what I'm doing here, all I've done is replace the h with 2r, and I've replaced the h with 2r. Now, we should know that r squared times r is r cubed, and we can do that in both places, r squared times r. Another thing we've got here is a third times 2, so we could write that as 2/3. So I've really got 2/3 pi r cubed from that, and I've got another 2/3 pi r cubed. Now I can collect these together because they're the same. I've got lots of pi r cubes and more pi r cubes. So I really need to do 2/3 plus 2/3. And 2/3 and 2/3 makes 4/3. And there you have, quite nicely, the volume of a sphere formula, which is given up here. Okay, so let's look at how you actually use it and some examples. So I've got a sphere, the radius is 4, the radius is from the centre to the outside. We need to type this into a calculator, so instead of doing 4 over 3, it's easy just to do 4 divided by 3 in the calculator. Use the pi button or 3.14, both are allowed in the exam. Make sure you're cubing the 4 though, it's 4 times 4 times 4, or use the v-cube button in your calculator, but you should be able to pop out as 267.95 metres cubed. In this example, we've got 10.2, but that's a diameter all the way across, so you need to half that to get a radius, and just do the same thing. 4 divided by 3 times pi times 5.1 cubed, or 5.1 times 5.1 times 5.1, type it in, 555.37 metres cubed. Okay, if you look at this kind of idea here, these are going to be snow globes and things, you shake them, they're quite nice, and the snow falls. But this is actually called a hemisphere. It's not a semi-sphere, which some people think, like a semicircle is half a circle. It's half a sphere, which is called a hemisphere. Now, let's have a look at how to work out the volume of this thing. Now, because you've halved the sphere, we just use the same formula, but divide by 2. Now, again, we've got to use the same idea as before. This is a diameter we've been given, which is 6, but I only want the radius of my formula. See, there we are. That means radius, so I'm looking for 3 here. So 4 divided by 3 times pi, or 3.14, times 3 cubed, divided by 2. You could write 3 times 3 times 3 if you want. But type all that into your calculator, should pop you out with the correct answer, 56.52 centimetres cubed. The last one I'm going to look at here is a combination of a hemisphere and a cylinder. Now when I'm doing this, I like to split it into two different shapes. I kind of like to name the shapes I'm working with. So I put wee headings. So we'll do the cylinder first. And again, if you're not sure of the formula of a cylinder, look back at the previous lessons. But it's pi r squared h. And again, what we have to do is identify the radius and the height. So the radius is 5. That's the diameter of the cylinder. So we want to do pi times 5 squared, and the height is 8. Okay, and if you take that into your calculator, 628 centimetres cubed. The hemisphere just does the same formula as above, 4/3 pi r cubed divided by 2. For this formula, we need the radius of the hemisphere, which would be from there to there, or there straight up. I'm going to go from there to there, which is 5, same as the cylinder. And if we type that all into the calculator, we'll get 261.67. Now it's the total volume we're after, so make sure you add them together and total up to get 889.67 centimetres cubed.